All right, how you guys doing today? Hopefully you enjoyed your weekend. I apologize, there might be a little background noise today. My children are watching Frozen 2, so if you hear those songs, you can just kind of ignore them. But today we're going to be moving on with the quadratic formula. It's going to look very similar to the problems that you did last week, but you're going to notice towards the end there's going to be a slight twist that we didn't have last week. So kind of bear with me. First example here is f of x equals x squared minus 3x plus 4. So if we're looking for the roots or the zeros here, we're going to start by writing our quadratic formula, just like we did last week. So I'm going to write x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. So I'm going to substitute in the values just as we did last week. So my b here is negative 3. So a negative b is going to be positive 3 plus or minus the square root. We're going to have negative 3 squared minus 4. A is going to be 1. And my c here is going to be 4. All divided by 2a. All right, so just like we did last week, once we've gotten the value substituted in, we're going to just put this piece right here into our calculator. Now, we'll learn more official terms later, but this piece right here is actually what's called the discriminant. We'll talk about that in some later lessons. But in our calculator, we're going to type in negative 3 squared minus 4 times 1 times 4. So we're going to end up getting x equals 3 plus or minus square root of negative 7. Oh, forgot to substitute my 1 in here for a before. Divided by 2. All right, now what's a little different about this one than from last week is inside of this square root, I now have a negative value. Now, if you remember back to earlier this year, things that have a negative inside of our square root, we can't calculate at this time. So when you see this in the quadratic formula, you can kind of stop right there. This indicates to us that there are no real roots. In other words, there is no x-intercept in this particular example. In fact, if you were to graph this on your calculator, and you can feel free to plug this into your calculator and graph it, if we were to graph it, we would get something that looks something like this. This is just a rough drawing, but as you can see, this vertex is not going to cross here. No part of our quadratic is going to cross the x-axis. So this is an example where we have what's called no real roots. So if you're going through and you end up with a negative value in here, that means you have no real roots and there are no x-intercepts in this example. You'll learn in Algebra 2 some ways that you can simplify negative inside the radical. But for our course, we're just going to be saying this as no real roots, or sometimes you'll hear it as no, only imaginary roots. All right, let's do one more quick example here, so you can see this, and then I'll get you out of here. So y equals y equals x squared plus 4x plus 5. I'm going to write my quadratic formula so I can find my roots. So x equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. All right, so again, I'm going to substitute my values in. My b here is 4, so this is going to be negative 4, plus or minus the square root of 4 squared minus 4. A here is 1. And c here is 5 divided by 2, and my a here is 1. All right, so Now I'm at this point where I'm going to simplify what's inside the radical. This is also known as my discriminant. So we're going to have x equals -4 plus or minus square root 4 squared minus 4 times 1 times 5. Again, feel free to put that in your calculator. Just make sure you're putting parentheses where needed. And we're going to end up with a -4 in here divided by 2. Now at this point, same thing as the last time, you're going to notice that we've got a negative inside our square root or our radical. This can't happen with real numbers. So we can stop right here and say this example has no real roots. Okay, this is not always going to happen. Obviously, we did a lot of examples last week that had 2 solutions, but in some cases this will happen. And in these scenarios, this just means that there are no real roots. It doesn't mean that you've done anything wrong if you end up with a negative inside the square root. All right, you know how this goes.